Class 10th math, class 10th maths, R.S. Agrawal, exercise 1D, question number 4. Prove that 1 by root 3 is irrational. Proof. We can solve as 1 by root 3 is equal to 1 by root 3 multiply root 3 and root 3. Numerator and denominator multiply by root 3. We get root 3 by 3. Root 3 by root 3. It means 1 by 3 into root 3. We know that product of rational and an irrational is an irrational. Hence 1 by root 3 is an irrational. By second method, we can also solve it. As solve as second method. Question number 4, 1D. Let 1 by root 3 is a rational number. Then we can write it 1 by root 3 is equal to a by b, where a and b both are integers and b is equal to not 0. Next step, root 3a is equal to cross multiplication root 3a into 1 or b implies root 3 is equal to b by a. This equational form of integers shows that root 3 is a rational number. It shows that our supposition is totally wrong. Hence 1 by root 3 is an irrational. Proved. Question number 5-2. Question number 5-2. Give an example of two irrationals whose sum is irrational. Give an example. Give an example of two irrational. Give an example of two irrationals whom sum is rational. Solution. We have to show that sum of two irrationals is rational. First, let first irrational number is 2 plus root 3. Sum of rational or irrational is irrational. And another is 2 minus root 3. Sum of these number 2 plus root 3 plus 2 minus root 3 implies 2 plus root 3 plus 2 plus minus root 3. 2 plus 2 is equal to 4. 4 is also a rational number. 2. Next question 5-2. Next question 5-2. Next question 5-2. 5-2. This question is give an examples of two irrationals whose product is rational. Give an example of two irrationals whose product is rational. 2 irrational. 2 root 3 is an irrational and 5 root 3 is another irrational. Their product 2 root 3 into 5 root 3 implies 2 into 5 into root 3 into root 3. 10 into 3 is equal to 30. A rational. Next question number 6 first. 6. Question number 6 first. The sum of two rationals is always rationals. True, false. The sum of two rationals is always rationals. 6 number questions. Question number 6. First, the sum of two rationals is always rational. Two rationals. Sum of two rationals. So 2 plus 2 is equal to 4. Sum of two rationals. 2 is rationals and also 2 is rationals. Their sum is 4. 4 is also rational. First, true. True. Second, the product of two rationals is always rationals. Product of two rationals. 2 into 2. 4. True. True. Third, the sum of two irrationals is always n irrationals. The sum of two irrationals is always n irrationals. Third, false. The sum of two irrationals. 2 minus root 3 plus 2 plus root 3. Both are irrationals. Their sum is 2 minus root 3 plus 2 plus root 3 cancels. 2 plus 2 is equal to 4. False है. Third, false. False हो गया. Fourth, the product of two irrationals is always irrationals. 4 number. False. The product of two irrationals. Root 3 into 2 root 5. 4 into 3. 4 into root 3 into root 3 is equal to 12. So, fourth, false. Fifth, the sum of a rational and irrational is irrational. The sum of rational and irrational. The sum of rational and an irrational. This rational 2. Sum of irrational 3. And irrational. True. 6. The product of a rational and an irrational. True. Question number 7. Prove that 2 root 3 minus 1 is an irrational. 7. Prove that 2 root 3 minus 1 is an irrational number. Proof. If possible, let or assume 2 root 3 minus 1 is a rational number. Then we can write 2 root 3 minus 1 is equal to a by b, where a and b both are integers and b is not equal to 0, implies 2 root 3 is equal to a by b plus 1, implies 2 root 3 is equal to b a plus b implies root 3 is equal to a plus b by 2. This equation so that root 3 is a rational number. So our supposition is wrong. Hence 2 root 3 minus 1 is an irrational. Proved. Next question number 8. Next question number 8. Next question number 8. Next question number 8. Question number 8. Question number 8. Prove that 4 minus 5 root 2 is an irrational number. Proof. If possible, assume that 4 minus 5 root 2 is a rational number. Then we can write 4 minus 5 root 2 is equal to a by b, where a and b both are integers and b is not equal to 0. Implies 4 minus 5 root 2 is equal to a by b. Cross multiplication 4 minus 5 root 2 is equal to a, implies 4 minus a is equal to 5 root 2, implies 4 minus a by 5 is equal to root 2. Sorry. This equation so that root 2 is a rational number. It means our supposition is wrong. Hence, we can say that 4 minus 5 root 2 is an irrational number. Next question number 9. Question number 9. Prove that 5 minus 2 root 3 is an irrational number. Proof. let 5 minus 2 root 3 is a rational number. Then 5 minus 2 root 3 is equal to a by b, where a and b both are integers and b is equal to not 0, implies 5 minus a by b is equal to 2 root 3, implies b 5b minus a is equal to 2 root 3, implies root 3 is equal to 5b minus a by 2. This equation show that root 3 is a rational number. It shows that our supposition is totally wrong. Hence 5 minus 2 root 3. 5 minus 2 root 3 is an irrational. Proved. Next question number 10. Next question number 10. In question number 10, what's question 10? Question 10, prove that 5 root 2 is irrational. Prove that 5 root 2 is irrational. Proof. If possible, suppose that 5 root 2 is a rational, then 5 root 2 is equal to a by b, where a and b both are integers and b is equal to not 0, implies root 2 is equal to a by 5b. This form of equation so that root 2 is a rational. It means our position is not true. Hence 5 root 2 is an irrational. Proved. Question number 11. Prove that 2 by root 7 is irrational. Proof. If possible, let 2 by root 7 2 by root 7 is a rational number, then we can write 2 by root 7 is equal to a by b, where a and b both are integers and b is equal to not 0, implies 2 root 7 is equal to 2b. No cross multiply, a root 7 is equal to 2b, implies root 7 2b by a. This form of equation shows that root 7 is a rational number. It means that our Jason is totally wrong. Hence, we can say that 2 by root 7 is an irrational. Proved. It's complete.